New Syllabus Mathematics Book 2 Updated 7th Edition Chapter Number 1 Primes, Highest Common Factors and Lowest Common Multiples. Exercise 1B, Question Number 9. Determine whether each of the following statements is true or false. If it is true, explain your reasoning. If it is false, give a counter example. First part from this question. If 6 is a factor of a number, then 2 and 3 are also factor of that number. The statement is true. Since 2 and 3 are the prime factors of 6, therefore, any number whose factor is 6 will also have 2 and 3 as its prime factors. Take a look at these examples. Number 12 is divisible by 6 because 6 is a factor of 12. But 12 is also divisible by 2 and 3, resulting in 6 and 4. Another number, 24, is divisible by 6, resulting in 4. Number 24 is also divisible by 2 and 3, resulting in 12 and 8. Another number, 60, is divisible by 6, because 6 is a factor of 60. But 60 is also divisible by 2 and 3, resulting in 30 and 20. Therefore, any number whose factor is 6 will also have 2 and 3 as its prime factors. Second part from this question. If 2 and 3 are the factors of a number, then 6 is also a factor of that number. This statement is true. The prime factors of 6 are 2 and 3, as the product of 2 and 3 is 6. Therefore, any number whose prime factors are 2 and 3 will also have a composite factor of 6, because the product of the prime factors 2 and 3 is the composite number 6. Take a look at this example. The product of 6 and 2 is 12. We say that 6 and 2 are the factors of 12. But we can also write the factors of 12 as 2 times 2 times 3. This means that if 6 is a factor of 12, then 2 and 3 are also factors of 12. In other words, any number divisible by 6 will also be divisible by 2 and 3. Similarly, the product of 6 and 3 is 18. We say that 6 and 3 are the factors of 18, but we can also write 18 as 2 times 3 times 3. Here, 2 and 3 are also factors of 18. Third part, if 2 and 4 are factors of a number, then 8 is also a factor of that number. The statement is false. For example, 2 and 4 are the factors of 4, 12, and 20. But 8 is not the factor of these numbers, which means these numbers are divisible by 4, but they are not divisible by 8. Fourth part, if f is a factor of n, then n upon f is also a factor of n. The statement is true. If n is a whole number and f is the factor of that whole number, then n is divisible by its factor f, because every whole number is divisible by its factor. To understand this statement, let's look at an example. Let f equals 3 and n equals 15, where f is a factor of n, because 15 is divisible by 3. Now dividing 15 by 3 results in 5. Once again, 5 is a factor of 15, which means if f is a factor of n, then n upon f is also a factor of n. Fifth part, if h is the highest common factor HCF of p and q, then both p and q are divisible by h. This statement is true. Since h is the product of common factors of p and q, therefore p and q are divisible by h. This statement refers to the definition of HCF, which states that the HCF of two or more numbers is the largest factor that is common to all the numbers. Take a look at this example. Let's find the highest common factor HCF of 20 and 40. Factorizing 20 gives us 2 times 2 times 5. Factorizing 40 results in 2 times 2 times 2 times 5. HCF of 20 and 40 is the product of common factors, which is equal to 40. If I match this example with the question, then P equals 20, Q equals 40, and H equals 40, which is the highest common factor of P and Q. Both the values of P and Q, which are 20 and 40, divisible by the value of H, which is 40. Which means if H is the HCF of P and Q, then both P and Q are divisible by H.